Alright, in this video we're going to take a look at working with our database. So the tool that we're going to be using to work with our database in certain contexts is the Entity Framework ORM, or Object Relational Mapper. Entity Framework is a library written by Microsoft that makes working with our database pretty straightforward. And we'll see a bunch of cool ways that we can use straight up C# classes to work with our database in a strongly typed way. We'll also see how Entity Framework can be used to keep our database schema up to date without losing data. And that's a really cool feature that's been recently added into Entity Framework. So some people might be asking why we aren't using a different tool such as Hibernate, or why we aren't using a micro-ORM such as Petapoco or Dapper. Well, the reason we're not using Hibernate is that Hibernate lost a couple core contributors over the last couple years and has gotten very stale, whereas Entity Framework, on the other hand, has been in active development. And a lot of the issues I had with Entity Framework have been resolved. So we're going to try out Entity Framework and see how it goes. We will be using the MySQL database, although we won't be using that starting off, and we'll show you guys why. As far as database access for the actual game, that's going to be split between using Entity Framework and using a micro-ORM. And the reason is Entity Framework provides a very nice way, or really any fully featured ORM, provides a really nice way to work with our database. However, they're not as performant as they could be. So for performance critical code, such as updating the position of the player in the database or something to that end, we'll be using a micro-ORM. But for our website and for other bits of logic, such as let's say adding an item from to your inventory, or something that doesn't happen very often when we need a transaction to complete and we want to take advantage of the features in ORM, we'll be using Entity Framework. There's nothing wrong with using two different database access strategies in the same project. We'll see how that works together later down the road when we talk about persistence from the game. But for persistence with the website and for certain aspects of the game, we will be using Entity Framework. So in this video, I want to introduce you guys to the framework and how we can use it to work with data. So I'm going to fire up a new project. It's just going to be a console application, and I'm going to dump it into our MMO class folder, and I'm just going to call it, I don't know, Entity Framework Intro. Seems like a good enough name. And then I'm going to hit OK. So the way Entity Framework works is it works from the context of what we call entities. An entity is an object in our database that has a unique identifier. So an entity would be, for example, a user or a character or something like that. There is a one-to-one correlation between the concept of an entity and a table in the database. So if you think about it, an entity is a class in C#, but it's also a table, and then every object of that entity, or instantiated from that entity, is a row in that table. And Entity Framework allows us to work with these entities. It's kind of in the name. Alright, so the first step is you have to bring in Entity Framework, and that's actually fairly straightforward. We simply right-click on References, go to our NuGet package manager, and you'll see that it happens to be the top downloaded NuGet package out of all of the NuGet packages. What is that? 4.9 million downloads. So we're going to go ahead and hit Install. We're going to have to accept the license. Also, Entity Framework is open source. If anybody's curious about how it works, just head over to the appropriate Codeplex site. So now that we brought in Entity Framework, nothing special really happens other than we get our Entity Framework references, including a reference to Entity Framework SQL Server implementation. Now, Entity Framework actually works with a variety of different databases. The one that is supported most by Microsoft, of course, is the SQL Server implementation, because Microsoft makes SQL Server. There are some challenges involved with getting Entity Framework to work with a database like MySQL, but once you get it set up, it's pretty straightforward, although there are a couple things you have to keep in mind as you develop. Now, the second thing that adding that NuGet package did was it added a bunch of stuff into our app.config. And when I say a bunch of stuff, I mean not a whole lot, but still some stuff that we're going to be coming back to pretty soon. You'll see that it added a config section up here at the top of our config sections, and it added the corresponding item into our configuration. And in this particular case, all it's doing is it's setting our default connection factory, as well as it's creating a SQL client provider for Entity Framework. That's because Entity Framework is pre-configured to work with SQL Server. But we'll be coming back to this item later to add support for MySQL. So the general process of working with Hibernate, wow, I'm going to accidentally say Hibernate a couple of times in this video. I just know it already. And if I say Hibernate on accident, know that I meant Entity Framework, unless I actually meant to say Hibernate.
It's kind of to be expected after so much time spent with it.
Yeah, I mean, I've been using Hibernate for since I started ASP.NET MVC stuff in 2009-ish. So yeah, which means that this will also be a learning experience for me too. And that's always fun. So the basic workflow of working with an entity framework is creating our entity classes. Now, like I said before, a class represents a table, objects instantiated from that class represent rows. So we're going to go ahead and create a couple classes to represent the kind of data that we'll want to store in our database. I'm going to create a new folder in our solution, and I'm going to call it entities. Seems like a sane thing to call it. Then I'm going to create two classes. I'm going to create a user class, and I'm going to create a character class. So now we have two classes, user and character, and right now they're, come back here. There you go. We have user and character, and right now they're both empty. These will turn into tables in our database. Let's fill out user first. For user, I'm going to give him a public int ID. Now, some of the stuff is, or there's a couple things that's important to talk about with this line. The actual definition of an entity from a computer science standpoint is an entity is an object that is uniquely identified. For example, I would be an entity and Steve would be an entity because we have a unique identity. Even if our attributes or data was the exact same, there would still be two instances of us. The same isn't true for an address, for example. An address is not an entity because an address, if two addresses are the same, conceptually they are the same thing. It's like if you have two number ones, those number ones are conceptually the same thing. But if you have two dogs, even if they're the same breed and they're, I don't know, twins, do dogs ever have twins?
Well, no.
Okay. Well, still.
I mean, you have like 8 at a time, but I guess I don't know if they actually have genetically twins or not.
Well, let's say that they did for a second, and if we have two of them with the exact same attributes, they're still separate concepts. They're still separate things. Which means we need an additional piece of data to identify our different entities, regardless of if they share the exact same properties otherwise, and that's going to be our D column. Our ID column is going to be a primary key, which it means that it's going to be in our database unique per row. We will never be able to have two users with the same ID. The important thing about what I'm showing you guys right here, though, is this. I'm taking advantage of an entity framework convention, and that is if we have a property named ID, it will use that as our primary key by default. Now, we can't override those conventions, and we'll talk about overriding conventions later. Another thing you'll notice if you have an Hibernate background is the lack of virtual. In Entity Framework, we do not need to add virtual to all of our properties, but we will in certain cases. Whereas in Hibernate forced us to add virtual to all of our properties. And the reason for that is that Hibernate does not support, or maybe it does, but it does not enforce the lazy loading of individual properties. But it does support lazy loading of navigation properties. We'll talk about navigation properties shortly. We could have also named this column user ID, which is another entity framework convention, which will map this to the primary key. However, I always prefer, always since the dawn of time, I've always had a column named ID, which is the primary key of the table. Next up, let's go ahead and add some more data to our user's entity. I'm just going to throw in some simple stuff like a public string username, and let's do a public string password. And then let's do a public virtual iCollection of character. Okay, so I added a couple other bits of data that we can add to our database. Username, a password, and a collection of characters. Note that the collection is indeed marked with virtual. And that's because Entity Framework behind the scenes will actually dynamically create a new class called a proxy, which will inherit from user and then override our implementation of characters, which is really cool. It does this all behind the scenes, and the reason it does that is so that it doesn't load the navigation property, which this is a navigation property. It won't load it until we access it, which is an example of lazy loading. That's because every time we load additional data from our database, it will result in Entity Framework being required to generate the corresponding SQL, send it off to the database processing that SQL, then returning a result. So we want to make sure that we mark all of our navigation properties as virtual. Now, there's a couple other things that I'm going to do here. I'm going to mark both username and password as required. Now, required is going to be an attribute that we're going to see quite a bit of because it comes from the System Component Model Data Annotations namespace. Data annotations are a way with many of Microsoft's products and other open source products that allow you to annotate different properties of a class in particular ways to give them more semantics. We'll be using them quite heavily with our ASP.NET MVC site to mark particular properties on our view models in particular ways. But fortunately, an Entity Framework also understands data annotations. So I'm going to bring that in, and that'll bring in a using statement up top there, System Component Model Data Annotations. I'm going to mark password as required also. Also, the last thing I'm going to do is I'm going to use another data annotation on username. I'm going to set its max length to 128. Now, these attributes actually won't really do anything just yet, but we'll see where they're used later. So let's go ahead and open up our character. Now, our character, we're going to have a one-to-many relationship between users and characters. So a user can have multiple characters. We see one side of that relationship here with our iCollection of characters on our user entity. Now on our character class, we're going to create the other side to that relationship. But before we get to that, we of course have to add our primary key. If we do not have a primary key, that we either configure by convention in the case of naming our property ID, or configure by code, which I'll show you guys how to do later, then we won't be able to use this entity with Entity Framework because it's not an entity. If it doesn't have an ID, it's not an entity by definition. Next up, our characters need names, and our names are going to be required. So again, that brought in System Component Model Data Annotations. Finally, I'm going to put the other side to this relationship in. So I'm going to say public virtual user, and I'm going to mark him as required too. So the public virtual user will allow us to navigate from a character back to a user, and our character or iCollection of characters will allow us to navigate from our user to the characters that are owned by that particular user. And we'll go over how this is actually modeled in the database very shortly. So really, that's the most interesting code that we need to write in order to work with Entity Framework. The only other bit that we have to write, the bare minimum to work with Entity Framework, is going to be our data context class. Now, our data context class effectively is a session factory, if you're familiar with hybrid. It's actually a combination of a session factory and a session. What I mean by that is the data context class is what we're going to be using to interact with our database. It's going to contain the connection to the database, but it also has to be made aware of which classes in our project are supposed to be managed by Entity Framework. Because right now, we haven't told Entity Framework that we want it to manage either of these classes. So let's go ahead and do that. We do it simply by creating a new class, and I'm going to call this class test context. And this class is going to inherit from db context. DB context comes in from system data entity, which is the main namespace when working with Entity Framework. And it's basically basically what I just said. It's represents a combination of the unit of work and repository patterns, such that it can be used to query from a database and group together changes that will then be written back as a unit. So now we have to inform our test context or inform Entity Framework which of the classes that we wanted to work with. And we do that through saying, this is kind of weird, but it kind of makes sense, I guess. We say public db set, and then our entity, which we're going to have a user, and we're going to call it users. And I'll have public db set characters. And this is the bare minimum that we need to do to configure Entity Framework with two entities that share a one-to-many relationship. So that's not a whole lot of code, but there's a lot of stuff going on behind the scenes. So by creating these two properties, we've told Entity Framework that these are two entities in our class and we want Entity Framework to treat them as such. We also, when we instantiate test context, will also gain access to these two tables. So again, you can think of this users property as the user table and this characters property as the character table. So to use this, let's jump into our program.cs and let's go ahead and insert a user. So first thing we need to do is we need to open a connection to our database. So we're going to say var using var, we're going to say database equals new test context. Now we have a open connection to our database. And of course, when we exit the using block, the connection will be closed. Then we can say something like var name equal, let's build a prompt. I'm going to say console write enter a name colon var name equals console read line. Okay, so we've extracted a string name from the console. Now let's go ahead and create our user object, or a user object. So I'm going to say var user equals new user. And of course, I'm going to have to bring in our entity's namespace. I'm going to say username equals name, and then password equals 123456776, because that's the best password that you can use. Okay, so we've opened a connection to our database. We've asked the user for a name. We've instantiated a new user object. Last thing we need to do to actually insert this object into our database is to tell our database about it, and then tell our database to commit all of our changes. So, to tell the database about our new object, we simply say database.users.add user. Now remember, this users guy right here, this is our property that we wrote on our class that inherited from DB context, which tells in Hibernate about our user entity. And by doing database.users.add user, we have informed Entity Framework we have a new object, and we want it to be saved to the database. But we haven't told it yet to actually save it to the database. That's because Entity Framework will batch all of our changes that we may have done to our entities, and then wait for us to tell it when to save. To save our changes, we use the not very surprisingly named save changes method, and we're done. So let's go ahead and hit F5. Let's go ahead and enter a name. And that was super exciting. Now, I'm sure a lot of you guys have some questions. Where is the database? And how did its schema get created and all of that fun stuff? Well, let's just ignore those questions for a moment here and talk about querying data. And then we will get back to where the data actually went on our computer, because I want to prove to you guys that we have actually opened a real connection to a real database somewhere on my computer that's going to be saving data. So to query data, we interact with our dbSet properties. So again, our dbSet properties is in this case going to be users and characters. So by interacting with these two properties, we will be able to query data from our database. So let's go ahead and write a query that will return all users in our database. So I'm going to add a couple lines of code up here after we open our connection. I'm going to say var users equals, well, actually, you know what? I can just do for each var user in database.users. Well, it's not going to let me use user because I use it down here, so I'm going to say var saved user in database.users, and then I'm simply going to say console write line saved user dot, or I'll do blank blah blah blah, and I'll do saved user ID, saved user username, saved user password. So what's going on here is we're looping through all of the users in our database. So that's the reason why this works is the dbSet class inherits from IEnumerable, which allows us to use it in a for each loop. When the for each loop hits this property and tries to access its getEnumerator method, Entity Framework will actually fire off a SQL query to our database to retrieve the data. Then it'll take the result of that data, or of that SQL statement, and it'll hydrate them into strongly typed user objects, which we can see right here that we are indeed returning our user entities. So let's go ahead and hit F5. So we see 1, Nelson Lequet, 1, 2, 3, 4, 5, 6. That's the user I inserted previously. Let's go ahead and type in another one, hit enter. Then let's hit F5 again. And we'll see 1, Nelson Lequet, blah, 2, another one, blah. So a couple important things to note about this. You'll see that our IDs are not being set by us, they're being set by the database. The default strategy for an integer primary key is going to be an increment. So every additional user added to the database is going to be the ID value incremented by 1. So yeah, we have data and we can retrieve data. We'll talk about more advanced querying later, but for now we can see that we can insert and retrieve data, but from where? If you're familiar with ORMs, and Hibernate or any other ORM or really any other database strategy, your first place to look would probably be under your app.config, and you'd be looking here for your connection string, which in .NET terms, a connection string is a piece of data that describes how to access a database or a relational database. But we don't see any. That's because Entity Framework likes to do a lot of magic, and some of the magic I like, some not so much. They really wanted to remove the barrier to entry as much as possible, meaning they really wanted us to be able to write this minimum amount of code to be able to have a working application. Our database is actually going to be on my computer a SQL Express instance. What Entity Framework did was it first checked to see if I had SQL Express installed, or any SQL server, any MS SQL server installed. It found that I had a SQL Express server installed, so what it did is it's automatically connecting to that. It's using the name of the assembly as a database name. It automatically created that database, and then it inspected our entities and automatically created the appropriate schema to work with our classes. Now, if you don't have MS SQL installed, what it'll do is it'll use another database called LocalDB. LocalDB is a fairly recent database system written by Microsoft that effectively is just a SQL Express server, but in a self-contained file. So as opposed to having to install SQL Express on your computer, you are able to work with a file, an MDF file, that contains your schema and your data. Now, LocalDB is great for development, but it isn't so much for production. You should never, ever, ever, ever use LocalDB for production. So let's go ahead and fire up MS SQL MSE and take a look at our tables. By the way, MS SQL MSE is Microsoft SQL Server Management Studio Express. Just say that 5 times really fast.
No. I refuse.
Okay, let's wait a year for it to load. Here we go. Alright, so it's going to ask us to connect to a server. In this case, we are connecting to my local server using Windows Authentication. Note, if it did create a local DB database, You should be able to find it. Should add it to the project. I've actually never used LocalDB before. If it doesn't, go ahead and show all files. Track down your LocalDB database and add it to your project. Then you'll be able to double click on it and edit it from within Visual Studio itself, as opposed to using something like MSSQL MSE. I do believe that it's going to require you to download some I can't remember what they're called, Microsoft Data Tools or something like that, which is a really quick download using the Microsoft Web PI. However, if you do need to install, it'll tell you and just follow its instructions. But again, that's only if you have a local DB created because you didn't have an MSSQL Express database installed. So if I come over here and open up databases, we'll see that we indeed have an Entity Framework intro.test context. I actually kind of lied. It's the name of your assembly plus the name of the class that represents your data context or DB context. Now remember, if we wanted to have multiple connections to our database, we could have multiple DB contexts. And that's why it scopes our names that way. And if we open it up and go to tables, we'll see we have 3 tables. 2 which should look pretty familiar and 1 that doesn't. So the 2 that look familiar are going to be our characters and our users. You'll notice a couple interesting things. Actually, that's funny because I was about to talk about pluralization, which I incorrectly did with the word thing. But you'll notice something interesting. The table that it created to hold our character entity is called characters, and the table that it created for our user entity is called users. Of course, we can override these names if we want, but by default, it'll just take the class name and pluralize it, which is a very common sort of convention when working with data. So if we go ahead and look at the schema that's created for characters, actually let's look at users first. Users will be simpler. So if we look at users, right-click and hit design, we'll see we have a couple interesting things. First of all, we do have an ID property, or an ID column of type int, and you'll notice it is the primary key. And we see that's the primary key because it has that little key next to it on the row. This isn't really that much magic. It's just Entity Framework decided or realized that we had a property named ID, and it took that to mean that would be the primary key. The next thing is you'll notice 2 instances where our data annotations were respected. Both our username and our password are set as not allowing nulls because they are required, and also our username is a nvarchar of 128. That corresponds to the max length, whereas our password is an nvarchar max. Okay, so that's our users table. It's pretty straightforward. If we right-click users and say select top 1,000 rows, we will see our users are indeed in the database. Now let's look at characters. So if we open up the characters entity, and then we right-click characters and hit design, we'll notice a couple interesting things. First of all, we see our primary key, we see our name as being required. We also see this, user ID. The user ID is used to represent the navigation property from characters to user. It's also used to represent the navigation property between user and character. That's because in order to load all of the characters that are owned by a particular user, we simply query the database for the characters table, seeing if, or with a where clause that says is user ID equal to ble, where ble is whatever user we're searching for characters on. So Entity Framework is smart enough to be able to use that one property or that one column for both our navigation property to and our navigation property from the relationship. You'll also notice because I set required on our user navigation property, it is not null. It doesn't allow nulls. In addition, if I go ahead and right-click and hit relationships, we will see fkdbo characters dbo users user ID. What is this? This is a foreign key constraint. What this means is we will not be able to insert a character that does not reference a valid user. So again, that's just a pretty straightforward implementation of a relational database. We have foreign keys, and foreign keys allow us to enforce the relationships between different tables. They're really one of the only ways to create relationships between different tables within an RDBMS. You'll notice down here our insert and update specification. We have a delete rule of cascade, meaning if we delete a user, all of his characters will be deleted as well. That's because if we delete a user, all of his characters who have their user ID set to his ID are no longer going to be valid. They're not valid because the foreign key constraint will fail. So yeah, Entity Framework did all of that for us. It created the schema for us automatically based off our classes. It even searched my computer for a database to stuff all the data in, and it ended up on my SQL server. My SQL server, get it? Because I was actually saying my SQL server, as in the SQL server on my computer, not MySQL. I hate
Waka waka waka.
All right, and well, the magic of Entity Framework putting all this stuff together comes down to the concept of a migration. Now, migration is effectively a way to transform a database schema into something else in order to update it throughout the course of development. That's because, well, our database has its own concept of our data model, and our source code has its own concept of our data model, and we really want to keep them in sync. Now the question then comes down to who is responsible for keeping the database schema in line with our code. For example, if I wanted to add an email property to our users table, who would be responsible for adding that in there? Well, in some organizations, that's going to be your DBA or database administrator, whose job is to do this sort of stuff. In other companies, you will have developers manually patching databases, which is really not a good idea. But for the most part, the industry standard way to handle this is through the concept of a migration. In just a general sense, not specific to Entity Framework, a migration is a bit of code, whether that be code in C# or code in SQL, that updates a database to match the way that we want to work with that database from our code. So if we wanted to add a users or an email column to our users table so we can have a email property on our users entity, we would write a migration either through DDL or I totally forgot what DDL stood for. Data definition language, I think. It's the DDL is a subset of SQL that allows us to manipulate our schema. So it allows us to add columns and stuff, or create tables or drop tables. But anyway, we would either write a script in DDL or we would write some C# that gets turned into DDL. The way that we run migrations is in development, we migrate frequently as we make changes to our database. In production, however, we would migrate when we pushed the new website or the new server live. So we would set the new server live, copy all the required stuff over, restart the server, whatever. Then the code within that server is going to update our database schema. An alternative way of doing this is to break the concept of migration into its own action in our continuous integration tool, but we're not going to be doing that. Instead, the way we're going to handle migrations is we're going to have our website, when it launches for the first time after being updated, it'll ensure that all of the latest migrations have been applied to the database. Now, this has an incredibly ridiculously important consequence that is incredibly ridiculously important to understand. Never edit the database schema directly. You'll see right here we're sitting in a tool that allows us to do stuff like I can add an email column, and then I hit Control-S, and now I have an email column on my users table. Never, ever, ever, ever do that. If you're working with a migration framework, such as Entity Framework or Fluent Migrations or Ruby on Rails or Laravel PHP or whatever, you're never going to want to modify your schema directly. Of course, you can modify your data directly, but that's different. So what is this migration history? Well, this migration history is going to be a table written by Entity Framework that allows its implementation of migrations to work. it's really not that important to understand other than just don't ever delete this table. You're not going to want to delete this table because then Entity Framework won't know what version the database currently is, and then when you go to apply a migration, it'll fail spectacularly. So if you delete this table, then you will have problems. So we talked about migrations, or the concept of migrations. Again, they're just ways to keep our database schema up to date for production and for development. But we haven't talked about how to use Entity Framework's specific flavor of migrations. Well, I actually find the Entity Framework migrations to be really, really cool. What they allow us to do is very common to migration systems is they allow us to write classes that have a up method and a down method. And each class represents a single migration, and so that they will be applied when the database or when the web server is updated and it causes the migrations to happen. Well, let's actually go ahead and do something to represent a very common error that we'll run into within Hibernate before we talk about actually adding migration support in. Let's go ahead and add a public string email field and just make it required because why not? Jump into program, and then I'm going to set email. Oh, come on. I did that to my characters, didn't I? Why don't you stop me from adding that to my characters, Steve?
Because I'm hopelessly inept at coding.
Okay.
That's my answer for 400.
Okay. Well, let's get our email field properly on our user, and then let's jump back into our program and say email equals blah. Let's hit F5, and we get an invalid operation exception. It says, the model backing text context has changed since the database was created. Consider using code-first migrations to update the database. Well, if you follow this link, you'll get a bunch of handy documentation about how to use the code-first migrations. But like most things with Entity Framework, it's pretty simple to do and fairly easy to remember. So I'm going to hit stop. Then I'm going to go up to my tools. So this is important. We're going to want to do two steps. We're going to want to create our migrations. And then we're going to want to enable our migrations and create it. So to do that, we're going to use a couple PowerShell scripts that are installed with our Entity Framework NuGet package. To access them, we'll go to our Tools menu, Library Package Manager, and Package Manager Console. And then I'm going to make sure it's not, there we go. So within the Package Manager console, I'm going to say enable migrations and hit enter. Okay, so we get a couple of cool things. We, first of all, get our folder called migrations. So this namespace is where all of our migrations are going to be under. The next step, we get a actual migration as well as a configuration class. Now this configuration class contains a couple of important aspects that we'll talk about later, but you can think of it as the way that we configure the concept of migrations within this particular context. And you'll see that this context is actually scoped to this particular configuration by use of generics. So this is our configuration that allows us to change the way migrations work, but for the most part, it's pretty, the defaults are fine. Then we have an actual migration. So this migration might look a little scary, but in reality, all this is it's C# code that represents a modification to a database. So if we read this, we could say, we say create table, we create the characters table. The character table has a integer ID, which is the identity. Identity in MySQL is another term for primary key. We have a string called name, which is not nullable, and a user ID, which is int, which is not nullable. We give the primary key to ID. Oops, I got that backwards. Identity in MySQL is corresponds to auto increment. So it means that the ID will automatically increment every time a new row is added. Then you'll also see that we specify the foreign key. So it's actually going to go ahead and create the foreign key for us between users and characters. And then it's going to put an index on the user ID. And then we see the same action with this other one. Now you notice these methods are an up. Now the up method is invoked when we want to migrate from the old version to the new version. We'll also have a corresponding method called down, and down is invoked when we want to migrate from a newer version back down to below this version. And the reason we need both is for rollbacks. Sometimes you make a really terrible mistake that isn't caught by anybody, by your QA team or your automated testing or your integration or end-to-end testing, and you break production. And then you have to roll all of your changes back down so that the previous version that worked can be used while you fix your mistakes. The down method in your migrations allow you to support the concept of bringing a migration up and bringing a migration down, or applying a change or unapplying a change. Technically speaking, I suppose it's theoretically possible for an up or for a down to be generated from an up, but in a lot of cases it's important that they're separate. So that's why it looks like there's some repeated logic here when we're creating characters and users and then we're dropping characters and users. But that's all right. So we now have a initial create migration. Now, I don't think you'll get an initial create migration if you didn't have an existing database that was created with Entity Framework. In that case, you would have to add a new migration. To add a new migration, the workflow is actually incredibly straightforward. One way to do it is I could say add migration bleh, or let's say we want to add that email field to our users table. So I'll say add email to users. Now we could hit enter right now and we'll create an empty blank migration, but we can actually do a lot, or make Entity Framework do most of the heavy lifting for us. We do that simply by going to our users class and seeing that we already added the email column in. You'll notice that the email column is not present in our initial create migration because it wasn't present in the database. This initial create migration was created from the database, not from our model. So we make a change, and in this case this change has already been made, and then we go ahead and we say add migration. Hit enter. And look at this. We get a new migration, add email to user, and that new migration indeed has code in it that adds the email column to our database. So you might think you might be able to go ahead and hit F5 and have it run, but you'd be wrong. As you see, we still have that exact same error that we had before. And that's because although we've created the migration that's going to add the email column to our users table, we haven't actually ran that migration yet. To run the migration, we simply say update database and hit enter. And you'll see it said applying explicit migration, add email to user, and applying explicit migration, add email to user. So it's kind of redundant in that case. You'll see if I hit update database again, it won't do anything because it says no pending explicit migrations, and then it's run the seed method. We'll talk about the seed method later. If I come back here, we'll notice a couple interesting things have changed. First of all, our migration history will now have 2 entries in it, specifying that we've ran 2 migrations against our database. Then, if we go into users and hit select top 1000 rows, we'll notice we actually now have an email field, which is exactly what we wanted. Which means we can come back here, hit F5, and we won't get any errors. Alright, so that pretty much wraps up the basic introduction to Entity Framework. We talked about some of the coolest features of it, particularly the migration stuff. I love that. Let's actually go ahead and add a new migration in, just to show that process one more time. I'm going to close all my documents to get rid of the clutter. Let's go ahead and add a new entity. Let's add a an inventory item entity. It's going to have public int ID. It's going to have a public string name, I guess, which I'm going to set as required. And then we're going to have a public virtual character, which is the character that owns this particular entity inventory item, which I'm also going to mark as required. So we've added a whole new entity. We've given it our primary key, our name. We've marked the name as required. We've created a navigation property from our inventory item to our character. Now I want to create the inverse of this relationship by coming into the character class and saying public virtual iCollection of inventory item, and we're going to call this inventory. So now we have the concept of an inventory for each one of our characters. So our characters have a list of inventory items which represent items in their inventory. So if I were to run this code right now, it would fail, and the reason is the database hasn't been updated yet. So how do we update the database? Well, first we need the migration. So I'm going to say add migration. I'm going to say create inventory item entity, and I'm going to hit enter. And you'll see Entity Framework generated this whole class for us that contains all of our columns, it contains our foreign key, and it contains the corresponding down method. So now let's go ahead and apply this migration to our database. I'm simply going to say update database, hit enter, and it's applied. If I come back to MSSQL MSE, right click and hit refresh, we will see we now have an inventory items table. Okay, so in this video, we showed you guys how to get started with Entity Framework by first creating our entities, which again are just classes, then creating our database context, which is basically telling Entity Framework about which classes in our project correspond to entities that it should track. Then we used our database context in our program file to loop over all of our users in the database, as well as insert a new user to the database. And then finally, we looked at a very, very convenient, very, very easy to use way of managing our schema without having to resort to custom made SQL scripts or having to mirror database changes in production, which is really not a good way to go about handling changes in your schema. So yeah, I think that about wraps up what I wanted to show in this intro.
Awesome.